One more quick question. Draw the Lewis dot structure for SO32 minus ion, and then determine the following things. Okay, so first let's write out the Lewis structure for the ion. Let's find the total number of valence electrons. So for sulfur, there's 6. Oxygen also has 6 valence electrons, and there are 3 of them, so we multiply by 3. And since there's a 2 negative charge on the ion, we're going to add an additional 2 electrons to our total count. So this gives us 26 valence electrons in total. So now let's draw sulfur as our central atom. And then I'm just going to show all the oxygens around it with single bonds. And notice that sulfur, well, actually first I'll just draw in all of the valence electrons with a lone pair on the sulfur. So now let's count out how many I've drawn so far. 24 plus 2. So we have 26, but all of these 3 oxygens will have a negative charge, but we want an overall charge of -2. So for one of the oxygens, I'm just going to make it a double bond. And now we still have 26 electrons, and we have the desired charge of -2, and everything has a full octet. So this is the correct Lewis structure for this ion. So now let's analyze the Lewis structure so that we can answer the following questions. So our central atom, which is sulfur, has 1 lone pair, and it has 3 bonded atoms. So if we use our Esprit table, when you have 1 lone pair and 3 bonded atoms, for the electron geometry, you have a tetrahedral electron geometry. And for part B, what is the molecular geometry? We have a trigonal pyramid molecular geometry. For part C, what is the hybridization of the sulfur atom? We have an sp3 hybridization. And then lastly, for D, what are the approximate bond angles? So for the bond angles of sp3, we have 109.5 degrees. Okay, so let's see what the junior tutor said. They had the same Lewis structure. It's just a different resonance structure. Electron domain geometry. So I think they meant to put this as the molecular geometry. As you can see here, when they draw it out, you get a trigonal pyramid shape. I'm just going to fix that down there. Hybridization is sp3, and the bond angle is 109.5. So the definition of electron domain geometry is right. It describes the arrangement of bonds and lone pairs, but it's actually tetrahedral. So the